Welcome back to another FreeCAD tutorial. In this video, we'll be exploring the Sketcher Workbench and learning how to create conics in a sketch using 5 different methods. Get ready to dive into the world of conic curves. Before we begin, make sure you have FreeCAD open and the Sketcher Workbench activated. If you don't have FreeCAD installed, head over to the FreeCAD website and download it. Once you're in the Sketcher Workbench, you'll find various tools on the toolbar. Click here to add new document. Click on this icon to add a new sketch. Select plane and click OK. Turn on grid. Turn off auto constraints. Zero constraints. Zero elements. You can see that sketch is empty. Select drop-down list to select Conic Curve tool. You can see there are 3 ellipse methods, one for hyperbola and one for parabola curve. Method 1, ellipse by center, major radius, and point. With the ellipse tool selected, click on the center point of the ellipse. Then, move your cursor to define the major radius, and click again. Finally, select a point on the ellipse to determine its shape. Wonderful! You can see degrees of freedom here. There are 4 ellipse relational constraints. In Elements window, you can see 5 elements. First, ellipse curve. By clicking on it, you can see that curve is highlighted on working space. Second element is line, which is major axis. Third element is line, which is minor axis. Fourth and fifth elements are foci. Let's make sketch fully constrained. We will define an elemental property which are major and minor axis. Provide dimension for major axis. You can see here length constraint or distance constraint. 1 degree of freedom is reduced by using distance constraint. Select coincident constraint. It will reduce 2 degrees of freedom. Three degrees of freedom are remaining. You can see rotational degree of freedom about z-axis and minor axis length. Let's constrain rotation. Click on vertical distance constraint and lock the rotational movement. Constraint is added. Single degree of freedom, which is minor axis length. Use distance constraint and fix this. This error shows other constraint is selected. To unselect it, click anywhere in the working space. Define minor axis dimension. You can see that sketch is fully constrained now. To edit any dimension, double-click on it. You can edit by this method also. In the second method, we'll create an ellipse using the periasis, apoapsis, and minor radius. This method is particularly useful when working with orbital parameters. Select area to delete all elements, and press Delete key. You can see empty sketch. With the ellipse tool selected, click on the periasis point of the ellipse. Then, move your cursor to select the apoapsis point and click again. Finally, define the minor radius. Fantastic! You've just created an ellipse using the periasis, apoapsis, and minor radius. Degrees of freedom are the same as we have seen in first method. Elemental and constraint conditions are the same as previously explained. Let's make this sketch constrained. Select Distance tool. Define major axis. Define minor axis. You can see 3 degrees of freedom. Two for planar movement and 1 for rotation. Let's lock planar movement with coincident constraint. Let's lock rotational movement with respect to z-axis. You can see fully constrained sketch. You can edit any constraint by clicking on it twice. Moving on to method 3, we'll create an arc of an ellipse by specifying the center, major radius, and end points. This method allows you to create a partial section of an ellipse. Empty sketch. With the arc of ellipse tool selected, click on the center point of the ellipse. Then, move your cursor to define the major radius and click again. Finally, select the 2 endpoints to determine the arc's extent. Excellent! You've just created an arc of an ellipse using the center, major radius, and end points. These are the relational constraints. First, elliptical arc. By clicking on it, you can see that curve is highlighted on working space. Second element is line, which is major axis. Third element is line, which is minor axis. Fourth and fifth elements are foci. Here element is changed to elliptical arc. There are total 7 degrees of freedom. Let's reduce 2 using coincident constraint. Define major axis. Define minor axis. 3 degrees of freedom. Let's fix rotational degree of freedom. These 2 degrees of freedom are for endpoints. Let's lock these. You can see fully constrained sketch. To edit, double-click on any dimension. Method 4, arc of hyperbola by center, major radius, and endpoints. Sketch is empty. With the arc of hyperbola tool selected, click on the center point of the hyperbola. Then, move your cursor to define the major radius and click again. Finally, select the 2 endpoints to determine the arc's extent. Amazing! You've just created an arc of a hyperbola using the center, major radius, and endpoints. Seven degrees of freedom. Relational hyperbola constraints. In Elements window, you can see 4 elements. Let's constrain the sketch. Use coincident constraint to reduce 2 degrees of freedom. Let's lock rotational degree of freedom and 2 for endpoints. sketch is converted to fully constrained sketch. Method 5, arc of parabola by focus, vertex, and end points. Finally, in Method 5, we'll create an arc of a parabola by specifying the focus, vertex, and end points. This method allows you to create a partial section of a parabola. With the arc of parabola tool selected, click on the focus point of the parabola. Then, move your cursor to define the vertex point and click again. Finally, select the end point to determine the arc's extent. In solver messages, there are total 6 degrees of freedom. These are the relational constraints. In Elements window, you can see 3 elements. First, parabolic arc. By clicking on it, you can see that curve is highlighted on working space. Second element is focus. Third element is line between vertex and parabola focus. Let's constrain this sketch. Fix rotation and endpoints position. Fully constrained sketch. These constraints are defined. There you have it. You've learned how to create conics in the FreeCAD Sketcher Workbench using 5 different methods: ellipse by center, major radius, and point, ellipse by periasis, apoapsis, and minor radius, arc of ellipse by center, major radius, and end points, arc of hyperbola by center, major radius, and end points, and arc of parabola by focus, vertex, and end points. Thank you for watching this tutorial. If you found it helpful, please give it a thumbs up and subscribe to our channel for more FreeCAD tutorials. If you have any questions or suggestions, feel free to leave them in the comments section below. Happy sketching in FreeCAD!